Well, dear students, in the previous slides, we saw that the carburetor is not able to function properly. Simple carburetor is not able to function properly in the AB and BC region. So there are some compensating devices which we uh, attach along with the simple carburetor in order to function it well. So first one is the emulsion tube. So we can see this is the diagram of the emulsion tube, and it generally lies at a distance of 25 mm below the fuel level, and this is the main jet. This is the main jet, and this is the emulsion tube. So how does this function? The This is a well, and this well is filled up with the fuel, and as the supply of the air increases, the more and more fuel gets evaporated from the well, and due to its evaporation, these are the holes which are present in the well, or we can say it is a perforated well. These holes, they become exposed to the air, and as the speed goes on increasing, these holes, the fuel present in the well, it evaporates, and the holes gets uncovered, and due to their uncovering, the air content inside the air content inside the air fuel mixture increases, or simply we can say air fuel mixture increases. That is, the richness of the mixture is decreased. And now, since the richness decreases, the main function of this emulsion tube is to make the fuel leaner, or we can say it operates in the condition for the operation of the emulsion tube are in the region BC when we require a linear mixture. So we can very well note its function, and we can go to some other device which is given on the next slide. The next device is the compensating jet. Now, what is a compensating jet? The compensating jet, this is the compensating jet, which we can see in this figure. This is the compensating jet, and it is connected to the compensating well. It is also connected by means of an orifice. This is the orifice to the main float chamber, and this main float chamber, it gives way to the main jet, and this is the discharge nozzle of the main jet. Now, how it functions: as the uh, as the level of the fuel inside the compensating well decreases, it goes down. Similarly, the quantity of the fuel coming out from the compensating jet, it also decreases. So the fuel supply rate from the compensating jet is in direct accordance with the level of the fuel in the compensating well, or the compensating tank, we can say. Now, what happens? Since the fuel supply rate goes on decreasing as the air flow rate increases, this is one aspect, that the air flow rate and the fuel supply from the compensating jet, they are in inverse proportion. This we have to note first. Now, as the air flow rate increases, what happens to the main jet? The main jet provides more and more, that is the richer mixture. So they are in direct proportion with the main jet, the air supply rate and the fuel supply from the main jet, while they're in inverse proportion when we are concerned with the compensating jet. So these two opposite processes, they compensate each other, and they provide the correct mixture in the correct ratio, depending upon the state of the vehicle, in which region it is operating, whether in the region A, B, B, C or C, D. So we now move on to the next mechanism, which is nothing but the back suction control mechanism. One thing which we have to note, that in this system, this system mainly operates for the large carburetors, not for the smaller ones. We also can see that this is a large vent pipe, and this is supplied with a control valve, and this is, again, there is one small vent pipe also, and this is having an orifice. This is the main jet, of course. So what happens, there lie when the pressure difference between the when there exists a pressure difference between the fuel level, the top of the fuel, and the throttle and this venturi. not the throttle, this is the venturi, this is the throttle. So there does happen some there does occur the movement of the fluid from the float chamber towards the main jet or towards the venturi in this region. Now when the control valve is closed, so we can just erase all and we can discuss the role of the control valve in a better way. This is the control valve when it is closed, so it means the when it is closed there will be no flow fuel from the main jet, because the pressure level, because the pressure at the top of the fuel and that of the main jet and that of the tip of the nozzle of the main jet, it is same. So there will be no discharge of the fuel at this point. However, if we adjust the control valve, so by proper adjusting the control valve, a proper pressure differential can exist between the float chamber and the throat, and hence the quality of the mixture can be very well adjusted by that. By quality we mean the percentage of the gasoline or the petrol, fuel and air. So these were some of the devices which are required for the proper control and which are required for the proper and efficient functioning of the simple carburetor. So we will be discussing some of these devices in great detail in the subsequent videos. Thank you.